Welcome to part 2 of the experiment. In part 2 of the experiment, we're going to predict the Q point or operating point of the diode. The Q point is defined as the diode voltage and the diode current. So the way we're going to do that is we're going to drive the diode with a Thevenin source, 5 volts, and a 1K resistor, which we already happen to have. Okay. And then we're going to put our diode in forward bias over here, like this. And we're going to define the Q point is equal to ID comma VD. So ID is that, VD is that. Now we've already shown how to do this in part 1, where you measured ID and VD with a meter. Now we're going to show you another way to do that. And that way is as follows. If we take the IV characteristic of the diode, which you've already measured, and the IV characteristic of the Thevenin source, they are going to match. So what we're going to do is we're going to have the IV characteristic of your diode is going to look like this. So this is I and V. And now on that same graph, we're going to plot the IV characteristic of the Thevenin source. So if you remember doing load lines from Thevenin sources, let's do that in a different color for dramatic effect. For the Thevenin source, we're going to have the current here could be the ISC of the Thevenin source, the short circuit current. And over here, we're going to have the VOC, the open circuit voltage of the Thevenin source. And the magic of a Thevenin source is that no matter what kind of a load you hang over here, the I and the V have to fall someplace on this load line. So the ISC is equal to the V Thevenin over R Thevenin, 5 volts, 1K. And VOC is just equal to V Thevenin. So we have a point down there and we have a point up here. And we're going to connect those two with a line like that. And then where the IV characteristic of the Thevenin source meets the IV characteristic of the diode, that is going to be our Q point, right there. So from there, we're going to drop a line down here. That's our V sub D. We're going to drop a line over here. That's our I sub D. And we're going to graphically sketch these. You've already got this curve. This one you can sketch right on top of the graph. Where they meet, measure that, and then compare those with what you get when you have this circuit. So before you tear your circuit apart, set your source here to 5 volts with a 1K resistor, measure ID and VD, and see what you get. So we're going to measure VD here and ID there, and see how this ID measured compares with this ID calculated, how this VD measures with that VD. Traditionally, these have been very, very close, within 1 or 2%. So that's what you're going to be doing in experiment 2, in part 2. And so remember, the point of this is that we can use graphical means to predict the operating point, the voltage and current, even of a nonlinear device like a diode. So that's what you have to do for part 2. Go back to your setup, set your supply for 5, measure ID and VD. And then on graphs, you can do this after you leave lab. Graph these two curves, see where they intersect, ID, VD, compare them, give me a % error. That's part 2.